there are two ways we can find global maximum or minimum that depend on the interval, whether it's closed or whether it's open. So in case if we have a closed interval, first f has to be continuous on the closed interval a to b, and here we are guaranteed to have a global maximum and minimum. So the steps gonna be, first, find the critical point, that is where the first derivative is 0 or undefined, and then the second step, evaluate the critical points and the endpoints in the function of x, and then 3, based on our evaluation, determine what's the highest value and the lowest value. The highest value gonna be a global maximum, and the lowest value gonna be a global minimum. Now in case if we have an open interval or the domain is all real numbers, first f has to be continuous function on the open interval, and here I'm not guaranteed to have a global maximum or minimum. For the steps, it's gonna be, first, find the critical points, and then 2, evaluate only the critical points in the function of x, since here we don't have an endpoint. Then step number 3, determine if the critical points are local maximum or minimum. We can do this by first derivative test or the second derivative test. And then step number 4, check the behavior of the function of x as it approaches endpoints. So that can be as x goes to positive infinity or negative infinity, what's the behavior of the function of x. And then 4, based on these steps, decide what's a global maximum and what's a global minimum. Here again, remember that we are not guaranteed to have a global maximum or minimum when we have an open interval. Now we have this problem. Find the global maximum and minimum for the function x of x equal to x cubed minus 9x squared minus 48x plus 52 on the following intervals a, b, and c. So from a, we have the interval as from minus 5 to 12. Notice this is a closed interval, so we're gonna use the steps for closed interval. So first we're gonna find the critical point, then evaluate critical points and the endpoint in the function of x, and then 3, determine global maximum or minimum based on our evaluation. So first, to find the critical points, it's where the first derivative is 0 or undefined. So first we need to take the derivative. So here I'm gonna use the power rule. It will be 3x squared minus 9 multiplied by 2x minus 48. That's gonna be 3x squared minus 18x and then minus 48. Now I can factor 3 out and gonna be left with x squared minus 6x minus 16. Now I want to find two numbers that we can multiply them. It will result in the third term, which is minus 16. Then when I add them or subtract them, it will result on the middle term. That will be 2 and minus 8. So this formula will be factored into 3 multiplied by x plus 2 and x minus 8. This is the first derivative. Now, where's the first derivative as undefined? Notice the first derivative function is defined everywhere, including our interval from minus 5 to 12. So now we care about where's the first derivative is 0. It's gonna be 0 when 3x plus 2 multiplied by x minus 8 equal to 0. We'll take the first term and equal that to 0 to result in x equal to minus 2. The second term will result in x equal to 8. So these are our critical points. Notice that our critical points are in the domain of the function. That is between minus 5 to 12. That's our interval. Now for step 2, what I'm going to do, I'm going to evaluate our critical points and the endpoints in the function of x. So remember, our critical points here are minus 2 and 8, and our endpoint is minus 5 and 12. So now we have all the values at the critical points and the endpoints. So now we can move to step number 3. So we'll determine what's the lowest and the highest value of the function. So notice here, the lowest value of the function f of x is at x equal to 8, and it is minus 396. And the highest value gonna be at x equal to minus 2, and it's gonna be 104. Therefore, at x equal to 8, we have a global minimum, and then at x equal to minus 2, we have a global maximum. This is the graph of the function f of x. Notice our interval, it's between minus 5 to 12. So at 8, we have a local minimum, and also this is a global minimum since this is the lowest value of the function at this interval. And it's the same for minus 2. This is a local maximum as well as a global maximum since the value at minus 2 is the greatest on this interval. Always think of the interval given. Now notice what's the best upper and lower bounds of the function f of x. F of x gonna be bound by the lowest value of the function and the highest value of the function. So that gonna be between global minimum and global maximum on the interval. So global maximum at minus 2 and global minimum at 8. So f of x can be bound between negative 396 and 104. It should be the opposite. Now for part B, we have the interval between minus 5 and 14. Here, this is again a closed interval, so we're going to follow the steps of a closed interval. So first, to find the critical point from part A, our critical point are minus 2 and 8. These both are on the interval given, that is from minus 5 to 14. Now for the second step, we're going to evaluate our critical point as well as the endpoints. The critical point is minus 2 and 8, and our endpoints in here are gonna be minus 5 and 14. And then I'm gonna evaluate these in the function f of x. So I'm just taking the values of the critical point and the endpoints that we already did in part A. These are gonna be the same. Then I'm going to evaluate the function at x equal to 14. So now notice we have all the values. So now we can move to step number 3. So what's the lowest value and where's the highest value? Here the highest value is 360 at x equal to 14, and the lowest value is at 8, and it's gonna be minus 396. Therefore, at x equal to 8, we have a global minimum, and at x equal to 14, we have a global maximum. Now this is the graph of the function again. Notice our interval here, it's between minus 5 and 14. Again, we have a local maximum at minus 2 and local minimum at 8. Notice here at 8 the same, it's a global minimum, but at 14, since now it's the highest value of the function, therefore it's a global maximum. Now what's the upper and lower bounds of the function f of x? Remember, it's gonna be bound by the highest and lowest value, that's between the global maximum and global minimum values of the function. So that's gonna be between 360 and minus 396. Now for part C, notice in here on the right side it is an open interval, but on the left side it's the same, it's -5, which means it's a closed interval. So now we need to follow the steps of an open interval. First, we're gonna find critical points. From part A, critical point is -2 and 8. And notice they are in the interval -5 to infinity. Now we're gonna move to step number 2. We're gonna evaluate our critical points and the endpoints. Critical point again here -2 and 8, and the endpoint here is only -5. So these values already, we found them in part A and B, so I'm gonna just write them in here. Notice in here that -396 is the lowest value of the function. Note our interval on the function it's gonna be from -5 to the right. So notice in here, since at x equals 8 is the lowest value of the function, therefore this is a global minimum and local minimum as well. But here, as x goes to infinity to the right, the function of x also goes to the infinity. So that means the function of x is increasing as x increases. Therefore, we don't have the highest value of the function. Therefore, we don't have a global maximum. Now, note the bounds of the function of x. Remember, of x is going to be bound between the highest and lowest value, that is between the -396, that is the global minimum value of the function, and then between the highest value here we have infinity.